Welcome to lecture 56, which is on buffering and overlay analysis in GIS. In this lecture, you will learn very important part of the GIS, which is used for carrying out the analysis of the data when we have multiple layers. So there are various ways to integrate the data. So buffering and overlay analysis will be covered in this lecture. So let's begin the lecture. So this buffering is also called the proximity analysis, and it is very important in the sense that one pixel value could be correlated with the surrounding pixel. So we like to actually derive the properties from the neighborhood areas, and we call it the proximity analysis or the buffering, or sometimes around a particular feature we like to create a buffer and we want to find out the influence zone of a particular point or a feature, and then we like to plan in that particular area in a different way, and outside the buffer the planning is done in a different way. So if around a feature which is a point feature or a line feature or the area feature, if we are creating a corridor, if we are creating some kind of a mask around that region, that is called the buffering. Now, this is done in case of the vector data analysis. Buffering cannot be carried out with the raster data because that is available in the grid format. So, in this vector data analysis, the three types of features we are using to create a zone around that feature, and this normally what happens is that according to the shape of the feature, so the buffer also takes this similar kind of a shape. So it is parallel to that particular feature, and then we are using this buffering to carry out the overlay analysis. We can actually superimpose one map over the other map when we are creating. So buffering will give you the area. A point feature, for example, it is without area, it does not have any area, it has only the coordinates attached to it. But if I create a buffer around a feature, now I am able to get the area. So wherever we are dealing with the area also, and we do not have the area of the features, sometimes we create the buffer so that we know what is the influence zone of a particular point. So there are several ways of creating the buffer in a given feature. For example, in the polygon we can create a buffer inside the polygon and outside the polygon, that we will see here. Buffer zones will describe the areas around those real world features which are point, line and area features, and they will always be, actually buffer zones will always be around the vector features. A feature can have multiple buffers. So we may have one buffer, we may have more than one buffer around point, line and area features. Size also of the buffer, how much corridor we have to create from that, it will also determined by the user, and that is called the buffer distance. So sometimes with the experience, sometimes based on the literature review, we find out how much size buffer should be created, how much is the buffer distance which should be selected, and then we create the buffer around that feature. In polygon we are creating two types of buffer. One is called the inward, if we are creating inside the polygon, inward buffer, and another is called the outside buffer, we are creating outside the polygon. Now these buffer zones can be intact or they dissolved, like if there are 3 points and I am creating the buffer zone around those 3 points and they are very close to each other, I can leave it like that, and I can dissolve also when that common boundary I do not show, right, in both the buffers. So this besides the buffering and overlay, there are many other tools which are available with the vector data. So this is just the one capability which you are learning today. If you look at this slide here, we have point, line and area feature. So point has just the coordinates here, the line will have the length, and the area polygon feature will have the area and the periphery of that. So, we are creating a buffer around a point feature. Now, this is a circular buffer which is created. So, we are defining a certain radius. So, within a certain radius, that circular buffer is created. So, if we define that buffer distance, the GIS program will automatically create the buffers. Now, this is one, but if we want to create two buffers with radius R1 and radius R2, so there are two circles now around that point feature, and I will know the area which is covered by the radius R1 and the area of the circle which is covered by radius R2. So, now I am able to calculate the area of these features. Now, we look at the line feature. When we are creating the buffer around the line feature, so then we have to determine the distance from either side of the line. So, if I say 200 meter on either side of the line, the buffer is created. So, it will create a 200 meter buffer on both the sides. So, this is the buffer around the line feature, but again two buffers are created. So, one is 200 meter away, another is the 500 meter away. So, there are two buffer lines which are created around the line feature. Now, we see the polygon feature. So, in the polygon feature, there is a polygon and the buffer is created. So, again the buffer could be all outside or one inside, another outside, with the different distances from the actual polygon. So, you can create multiple buffers and then you can carry out a certain analysis within that buffer zone. For example, the line buffer which we have created, suppose there is a road and we have to widen that road. So, probably in order to widen that road, we will require a certain corridor whose survey will be carried out and the characteristics of the ground will be studied and some planning will be carried out within that zone area. So, that is why the buffer is very important. So, you can see here that this is the example of the buffer around the line feature. So, we have drainage kind of a network here and various drainages, the buffers have been created and they are created with the different distances. That means, in the entire map the buffering is not uniform. For some of the rivers the buffer distance is much larger, as you can see here. For other rivers the distance is smaller. So, there is depending upon the analysis, depending upon the requirement, we can create within a map itself, we can create the buffer with the different distances around the feature. This is a buffer zone which has been created around a road. So, you can see the brown one is a road and then around that a buffer has been created by a certain distance and then this is superimposed onto the map denoting the houses in that area. So, we like to find out, suppose we have created a buffer of 50 meter on either side of the road. So, we have a 100 meter corridor and we will like to see how many houses are falling within that 100 meter, because we have to widen this road. So, probably shifting of the houses has to be done. They are to be relocated to some other locations. So, we can see that this is the house which is just at the edge, this is another house which is just the edge. So, probably these houses are to be shifted to some other locations which are in the close vicinity of that 50 meter corridor. So, this kind of analysis is very helpful. When we superimpose another theme, we can find out what is the type of the land use falling in that particular area. Buffer around the point features. So, the dot here what you see is a point feature. So, we are showing, for example, the location of the well, or we are showing, let us say, the earthquake. This is the epicenter of the earthquake. Now, we are showing various circles here with the different diameter, different distance. So, that means we like to show here that the inner circle has more damages due to the earthquake which has taken place at that particular location as compared to the outer circle. So, as the distance, as you are away from the epicenter, the damage is lesser and lesser. So, sometimes these circles with different buffer zones with the different distances are conveying very good information to us. Now, when you are creating the buffer around a feature, it might happen that they overlap. So, as you can see that there are 3 point features on the top and there is overlap when you are creating the buffer with a certain radius. So, we have to dissolve them. This is the dissolved one where we do not show the overlapping between the two buffer zones, but we create just the outer boundary of the buffer, and this is the entire area which is covered by these 3 locations when we are creating the buffer of those 3 locations. So, this is the dissolved map which is used actually in analysis. This is this example of the campus safety that we are creating the buffer around lights in a parking lot. So, there is a parking lot here and you can see the buffers have been created around the parking lot in order to understand that how much is the area, which is the area which is still in the dark, and more number of lights are required from the safety point of view. So, one light electric pole will cover a certain area onto the ground, will illuminate a certain area onto the ground. So, that buffer zone indicates the area which is illuminated by the electric pole, and the areas within a given region where the circle is not there, it means these are the places where some more electric poles could be required. Now, the green spaces, if we have to know, what are the green spaces available near a particular site. So, for example, there are 2 polygons which are created at half a mile and quarter of a mile around the school. So, there is a location here at the center which is the location of the school, and we are creating 2 buffer in order to understand that what are the green spaces near the school, how far is the green space. So, we can see that there is very little green space which is available in the quarter of the mile distance, but there are then green spaces which are about half a mile away from the school. So, these green spaces could be the natural vegetation, or could be the forested area, or could be some reserve park area which cannot be disturbed. So, one can identify that how far away you are from those critical zones, whether this is the best site for the school or not. This kind of analysis can be carried out with the buffer. Now, this example is showing that when the buffer is created around the line feature. So, this line feature could be, as we know, the road, railway line, it could be a transmission line, it could be a river network or canal network. So, here the roads are shown, the bus routes are shown in the form of those connecting roads, and if we are creating the buffer around the road and we will like to know that how much is the area, if you take within the campus, if you take a ride, how much area will be covered in 15 minutes. So, that light shade here is indicating the area which you can cover in 15 minutes when you are travelling by road within this campus. But if you increase the time of travel, if you make it a 30 minutes ride time, then you can see the dark blue is the additional area which you can cover. So, you can cover this much of area in 30 minutes of time. So, may not be exactly in the same ratio, may not be exactly in the double, but you can find out how much is the aerial extent now, the area which is covered by a 30-minute ride, bus ride, and how much is the area which you can cover in 15 minutes bus ride. Now, around a polygon feature, so the middle line is indicating this is your actual polygon feature, and you want to create a buffer around that polygon feature. So, these are called bidirectional buffer. When we go inside by a certain distance we create a buffer inside, by a certain distance we create a buffer outside. So these are the bidirectional polygon, and many studies we have to create the buffer either inside or outside also. Now see the example of a river here. So there is the blue part is the river, which is meandering kind of a river. There are two branches and then it makes a single branch later on. So this is the flow of the river which is taking place. So what is happening is that there are some industries close by on both sides of the river. So those industries are also shown by the point feature. So you can see that these point features are showing actually those industries also. We create a buffer of the river, 500-meter buffer around a river, and we can find out which are the industries which are lying actually within that 500-meter buffer zone. So one can see that here this is the location where industries are just falling within that 500-meter buffer zone. So this means that it is quite likely that the water is being polluted by these industries, because they are situated just within the 500-meter buffer zone. But the industries which are away may be considered as the safe, they are not polluting as much to the river side. Now there are many other kind models are there, many other applications are there. As you can see here, this is entire model is indicating that you are creating the buffer zones, okay, of lake. So there is a map which shows the different types of lakes in the area. The buffer zone is created with the different sizes, and then there is a road map, a line map. Again the buffer is created around that road map, and along with that, it is along with these buffer maps other data is used. So this is the lake buffer map which is created, this is the road buffer map, and then it is merged with the wetland, carried out some overlay analysis of the entire data sets in order to get some kind of a suitable sites. So ranking of the sites have been done in terms of its suitability, because the site should be away from the wetland also, right. It should have the good connectivity, it should be away from the lake. So you can create that buffer zone and then integrate all the data together. When you are combining the buffers and integrating the data together, you are actually defining a certain rules, and then on the basis of that you are getting the output. Now there are certain Boolean operators which we are using. They are called the Venn diagrams also very popularly, and the concept here in these diagrams is that there are two maps, and these maps are shown in the form of the circles here, A and B. So A is one map and B is another map. So we here A is representing one theme and B is representing another theme. So when I say A and B, the Boolean operator, A and B indicates that I am talking of the commonalities between the two data sets. So this means that the hatched portion is the common portion which I wanted to highlight by this Boolean operators. If I say A or B operator, then A or B operator indicates the entire thing which is covered by the A and B together. When I superimpose them, A not B is indicating that it is not in B but it is in the A portion. So the highlighted one here, the hashed one, is indicating A, X or B is basically the excluding the common portion, whatever is the remaining portion that is there. So there are some examples which are given over here. So we are using these Boolean operators to overlay the maps together and extracting the useful information which is required. So here A map is the luxury hotels and B is indicating the hotels where we have more than 20 rooms. So if we look at these two maps, the location of the hotels and hotels with more than 20 rooms. So when I say A and B, which hotels are in the luxury category and have more than 20 bedrooms. So if I have this kind of a query, then I can get actually that common area highlighted between the two. So it will actually try to search out those hotels which have more than 20 rooms. The hotels which have less than 20 rooms will be neglected, will be discarded from the analysis. So on the basis of my query, what kind of a query I want to make from those two data sets, I can actually use this Boolean operator and get the answer of my that. Now this is a distance. The locations, for example, the white dots are indicating the locations, and I am creating 125 meter buffer zones, distance buffer zones around the hotels. So that is the proximity map. So what is in the proximity of the hotel? What are the different features? What are the different sightseeing places which are available in the vicinity? So that can be created. So these Boolean operators are very helpful actually to make queries. So I can make a query, I can club several maps together in order to make the query. This example I have shown with the help of the two maps only. For example, in the two maps, the query could be which are the luxury hotels have more than 20 rooms. This could be one query. The second query could be from the previous example, which are the hotels luxury or have more than one room. So here we have or, in the previous query we have the and examples. In the third query, which hotels are luxury but do not have 20 or more bedrooms. So I am talking of the every hotel which is luxury, which hotels are either luxury or have more than 20 bedrooms but not both. So in that case, I will exclude that common portion and see the entire other region. So it depends upon my query, what kind of a query is placed from the data sets. We can actually carry out that analysis, overlay analysis, and get the results. So this on the raster data also we can make the query. We can do the reclassification of the raster data, we can club, we can split, we can produce the Boolean images also, and for example, we have the land use map from the raster image, which is the classified from the satellite data. And if I want to make a query like where are all the forest area in my land use and land cover map. So I will show you, this is a land use and land cover map, this is a raster map. In the raster map, my query is I want to see the forest area. Where are the forest area in my study area? So these are all the black areas which are indicating are the forest area. So with the query, those pixels will be highlighted which are covered under the forest. So we can make query from the raster data also. So when we are doing the overlay operation, it is like simply putting up one drawing over the other drawing, putting one map over the other map. But think, when you have several maps together, when you have 20 maps, when you have 50 maps together, it is not possible to do it manually and try to see the output, how I am getting the output from those several maps which I superimpose together. So this in the GIS, the best part is that you can overlay different maps together as per the criteria which you define, and you can create a new layer. So there are various overlay operations available to us in the software. So you can combine the overlay them, point feature over the line feature over the polygon feature. So here see the overlay of the two maps. There is one map which is horizontally oriented, there is another map which is now vertically oriented, covering the different area. So if I superimpose these two maps, addition of the two maps, superimpose is like just addition activity. So one map superimposing with the second map. So this is the overlay results. I will get the common area, and within the common area my classes would be that within that box number 1 class A is present, within the box number 1 class B is present, like that. So I will get the output map with the overlay, and which is indicating the both the classes which are present. So, when you are overlaying the vector data, you have to ensure that you have created the topology and the topology is correct. When you are intersecting one line map over the another line map, you will create several other lines. You may create several other polygons. So, you have to actually ensure the correct topology when you are doing that. Now, when you are superimposing that, you can have point in polygon, line in polygon, polygon in polygon superimposition. So, point data in the polygon data. So, this is the example of that. It is indicating I have layer 1 with me, which is a point data. There are 3 meteorological stations 1, 2 and 3. In layer 2 I have a forest map, the forest category and the non-forest area. When I superimpose the point map onto the polygon map area, so I am actually getting this kind of a output. This is the new layer which is indicating the forest boundary, non-forest area as well as those 3 locations of the, and attribute table would be a point ID is 1, 2 and 3, and at that particular point ID what is the land use, forest cover or the non-forest area. So, I will have a new layer created, I have a new attribute table which will be created when we have point in polygon overlay. The second category here is the line in polygon. So, one map is the road map. So, we have a road map, there are 3 segments which are shown 1, 2 and 3 road map, and then the same land use map where we have the forest boundary and the non-forested area. This line map we are superimposing with the polygon map. So, when we are doing that, you can see here the additional nodes are created. So, because there is a boundary here, polygon boundary which is separating out forest from the non-forest area, and that particular polygon boundary is creating the additional nodes in my data set. So, topology has to be created here, and if you see the new attribute table, in the new attribute table we had the old ID and we have the now the new ID, and new ID is correlated with the all types of the forest cover. Polygon in polygon overlay. Now, when we are doing polygon in polygon overlay, there are various commands which we are using. We are using union command, we are using identity command, we are using the intersect command. So, as an example, it is shown over here, there are 2 polygons, again the forest area and the non-forest area is the first map, and then I have another map polygon area which shows a circle. When I try to intersect the 2 together using the union command, now we can see that there are 4 polygons which are created. So, 1, 2, 3 and 4 are the polygons, new polygons which have been created, because none of these maps had the 4 polygons available. So, we are creating the new polygons and we are creating from this a new attribute table. Let us see the case of the identity, where we are again superimposing these 2 maps together, and identity will be the common area between the 2. When we are talking of the common area between the 2, then there are only 2 polygons which will be considered here, 1 and 2, because I am only interested within that circle area only, which is the common between the 2 now, and outside that circle I am not interested. So, there are only 2 polygons. When we are talking of the intersect between the 2, so you can see here again superimposition of these 2 maps will basically intersect the circle. This particular dividing line will intersect the circle, and I have only 1 polygon in that case. So, these are denoted by union command, by or command, or identity by not command, and intersect by the and command also. When we are using these commands in any software, we are using either be these commands or union, identity and intersect command. So, GIS can give me answers to many of the things. Location, I can get the location where what it is. I can find out at a particular location what exists, or it could be situation and condition, where does it exist. So, I can actually what exists at a given location, or what is within the 100 meter of the road what is situated. So, that kind of a answer I can get from the GIS. I can also carry out the trend analysis, the change analysis. So, if I like to know what has changed over a period of time, whether the forest cover has been converted into the urbanization. So, I can carry out from the time series data, find out earlier this was a forested area and what is now. I can carry out the pattern analysis. What spatial patterns are available? What is the why there is a, for example, is why there is a major cause of death from cancer in this particular area. So, whether this particular area is near the nuclear power stations, we can try and see that kind of a pattern, try to establish. We can do the modeling from this data. What happens, if this happens? So, if a road is added to a new network, what will happen to the traffic density in that case, whether the traffic will be regularized or not. So, these are some of the examples which we can use the GIS in order to find out the answer from my data set. So, thank you very much. This is all about.